Hello, everybody. Actually, since it's very popular, buongiorno. That's an easy one because I'm obviously Italian. Luckily for me, in the first talk of this block, we have already heard about the current conditions of sea ice in Antarctica, thanks Nancy, and about the fact that we are right now in a moment with less sea ice than ever, basically, and this is something that has been going on since last year. But I hope that you still remember the previous minimum in terms of sea ice extent, which is the event that took place at the end of 2016. That's an event that followed some years in which we actually had sea ice extent above average, and then all of a sudden we had this big drop. And I'm going to say the word drop a lot of times during this talk. And then what is also interesting is the fact that since then the sea ice extent never really fully recovered, in the sense that we have observed negative anomalies since then pretty much all the time. So, of course, these events have been discussed a lot and described, and in particular, the driving mechanisms behind have been examined, and everybody agrees that this event was mostly triggered by the atmospheric conditions. But today's talk is actually about the ocean. What about it? Did it have any role in this event? Of course, this has also been analyzed, and in particular, very recently, some work suggested that there is actually a real contribution from the surface and subsurface conditions in the Southern Ocean to the drop, and also to how the negative anomalies persisted after that. So our idea here is to try to dig further into this and to really try to separate, as much as possible, the contribution of the atmospheric forcing and the ocean preconditioning to the drop, and also to how the anomalies persisted after the drop. And to do that, we played a little bit with this fully coupled model, Paraso, which is actually a regional model for the Southern Ocean. And first of all, we ran a control simulation, so a long run, in which the model is forced at the boundaries of the domain with reanalysis in the ocean and in the atmosphere. So the idea is that inside the model can evolve freely, and if it's a good model, then we should see pretty much what is going on in the observations. And then we run 5 sensitivity experiments in which we rerun the model, but this time starting in 2016, so January 2016, so a few months before the drop. And these sensitivity experiments have the same forcing as the control experiment, but we changed the initial conditions in the ocean only in January 2016. So in the member that is called IC 2001, we replaced the initial conditions in the ocean in January 2016 with initial conditions in the ocean in 2001. And then we do the same by picking some other years, so that in the end we have a nice little ensemble of 5 members. And I hope you see where this is going. The idea is that, okay, these members have everything that is identical except for the initial conditions in the ocean. So if we see any difference in terms of how the drop is captured and how the negative anomalies persist or not after the drop, then this is in principle related only to the ocean preconditioning. So first of all, we can just have a quick look at the control experiment just to make sure that our model is actually reliable. And this is the time series of the sea ice extent anomalies in the control run and in the observations. And we are happy to see that the drop is actually captured with a good amplitude and with the right timing. So the drop actually occurs in December 2016. And also that we have that the anomalies really stick to negative values after the drop until the end of our run at least. So good job, model. And also in terms of the regional contributions to this drop, these sectors that mostly contribute to it are the Weddell, the Ross, and the Indian Ocean. And in particular for us, these two, the Weddell and the Ross, are interesting because they contribute to the drop and also to the persistence of the anomalies after the drop. Okay, but this is the control experiment, so boring. We can move on to the sensitivity experiments, which are the interesting one. So, as I said, we start from different initial conditions in the ocean, which also mean, of course, different initial sea ice extents. And you can see that we have quite a variety in the sense that some members start from positive anomalies, other members start from negative anomalies. So now the question is, what about the drop? Is it there? Is it not there? What it looks like? Dramatic pause. Well, actually, eventually, all the members capture the drop, again with a good timing, suggesting that, yes, all the studies are right, and we can actually acknowledge the atmosphere as the main trigger of this event. And in particular, for our experimental setup, I remind you that it's a regional model, so we really force the model only at the boundaries, which is around 40 to 50 degrees south, which means that this boundary at the forcing is enough to trigger the drop. So it is really the large-scale anomalies that really drive the event, not just the local conditions. But also, I would like to draw the attention to the fact that there are some differences in how the drop is captured in terms of amplitude, and also, I don't have the time to show it here, but how the different sectors contribute to the event, so where the anomalies are really located. So this suggests that there might be actually some modulation by the ocean. And now, what about the persistence of the negative anomalies after that? Do we still stick to negative values after the drop in all the members? Other dramatic pause, we don't have time for that. Yes, we could say that overall all the members stick to negative anomalies after the drop. But again, we can see some differences, so there is a bit of spread in these curves and in how the single members recover, or actually not recover, after the drop. At least the differences are marked in the first year after the drop. Then eventually all the members tend to converge, and this is actually due to the setup of the experiment. But if we focus on the first year after the drop, we can see some differences. So we argue that there is probably some role played by the ocean, at least in modulating how the drop is happening and how the anomalies persist after that. So to understand a bit more what is going on, we focused on the different sectors, and for the sake of time, I'm going to show you only the results from the Weddell, which, as we have seen, is one of the key ones. And we can see that the spread is even larger for this sector, and we can see that there are some more evident differences in how the drop is represented in the models, in the members, sorry. So, for instance, some members do reproduce a very deep drop, which actually occurs a bit later compared to the control experiment and the observations in January instead of December. And we have some other members in which we only have a slight decrease, so not really a deep drop, which suggests that maybe in those members there is a contribution coming from the other sectors and not really from the Weddell. So the idea is now to really try to understand where are these differences coming from, and so to really look at how is the ocean different in these members. And again, for the sake of time, to avoid showing a million plots, that would be very confusing, I'm just going to show, to focus on two members, which are kind of the extreme ones, in the sense that IC 2004, which is the red line, is the member with the deepest drop, and also the one with the negative anomalies that, on average, in the year after the drop, are the strongest. And the other member, IC 2010, the purple one, is the one that only shows a little bit of a decrease, and then it still has, on average, negative anomalies in the first year, but they are just slightly negative anomalies. So one of the easiest things we can do is just look at the temperature in the ocean in these members. And actually, these are first the temperature anomalies from 0 to 500 meters in the control experiment, again, to have an idea of what is going on. And we can see that in the control experiment, we do have a warming compared to the climatology, which occurs pretty much between 50 and 150 to 100 meters that persist throughout the run, and it has been suggested this could be really contributing to the drop and to the persistence of the anomalies. And how about our two members? These are actually the temperature anomalies compared to the control experiment. And we can clearly see that the member with the strongest anomalies actually has a warmer ocean overall in the Weddell sector. And the other member, the one with the smallest anomalies, actually has overall a cooler ocean, at least until 200 meters. So we can see that there is kind of a straightforward link between the state of the ocean and the CS extent anomalies. Now, of course, these are the two easiest cases in the sense that we can easily interpret warmer ocean, less sea ice. For the other members, for some cases, we also have an easy interpretation. For others, we have a more complex interaction also with the anomalies in the salinity. But we can overall relate the anomalies in the ocean with what we see in terms of the drop and in terms of the evolution of the anomalies after that. So the key messages are, yes, the atmosphere is important, but so is the ocean, a little bit at least. And we think that it actually has an impact in at least modulating the drop, and it also has a little bit of a memory effect, at least for our setup. We can talk about the first year after the drop. That's all. Thank you.
Thank you, Bianca. Any questions?
Too fast.
Question here?
What about salinity?
Do you want to see all the dirty plots about salinity? Well, actually, to be honest, I think that we picked the years for the initial conditions a bit randomly, and I think that actually 4 out of 5 are saltier than the control experiment. And for one of them, this actually helps us to interpret the temperature anomalies too. For the others, it's a bit more complicated, but I'm happy to show all the dirty plots behind that.
Okay, thank you.
Thank you.
Okay, we'll move on to our next speaker. It's Aaron McClymont.
Oh, sorry.
Oh, sorry, you.